welcome back. This is the third module for the hands-on practice. We'll still be using the disease dataset for demonstrations. This video will be separated into several parts. We'll first learn how to use a new operator. Then, we'll look into 3 objectives. Last but not the least, we'll discuss the interpretations and applications of this data analysis result. Let's start with the first part, which is to learn about the pipe operator. The pipe operator looks like this, which is a combination of 2 percentage signs and 1 greater than sign. It is a function under the magritter package. Therefore, we need to install the magritter package in order to use this function. The pipe operator makes it possible to express a sequence of multiple operations in a compact and clear form. This means that we can use the pipe operator to write our codes in a clear form. Let's explain this concept with an example. Suppose that we have a data frame called data, and it has 3 columns, which are C1, C2, and C3. The values of all 3 columns are assigned randomly ranging from 1 to 10. If we want to get a summary result of C1 and C2 with values in C1 larger than 5, how should we write the code? There are 2 options. The first one is the way we are familiar with. As you can see from the side, each operation is written separately, and it is hard for us to understand the code at first glance. Another option is to use the pipe operator in the code. The data frame data is put first and followed by a pipe operator. This means that the later operations will be done on this data frame, or say we are passing data through the pipe to the function on the right-hand side. We will do 3 things to data, and all of them are linked with the pipe operator in sequence. Since we already specified the data frame at the beginning, we don't need to specify it in select, filter, and summary functions again. These 2 codes give us the same result. However, the second one is clearer and easier for readers to understand. This is the advantage of using pipe operator in our codes. Next, we'll be looking into the 3 objectives for the disease dataset. We'll also be showing you how the pipe operators work in the following demonstrations. Before we start with the demonstrations, please install these 3 packages into R. We'll be using functions from these packages. The first objective is to examine the death rates of each hospital. By understanding the death and recovery situation in each hospital, we are able to evaluate the effectiveness of medical treatments or identify problems in each hospital. Let's start with grouping the data by the hospital and outcome. Then, we should use the summarize function and the end function to count the number of cases. This table is too messy. Thus, we can use the pivot wider function to convert the rows to columns. We should set the columns to be outcomes, which will be death and recover. Next, in order to get the death rate, we need to add a new column to the table by using the mutate function. Inside the brackets of the mutate function, we name the new column as death percentage, and the values it carries are the death rates in percentage format. Run the code and we can get this table, which shows the number of deaths, number of recovered, and the death rate of each hospital. This code can be written in another way, which is to use the pipe operator to link the codes. First, as we are working with the demo data frame, we should put it in front of a pipe operator, telling R that the following operations will be done with this specified data frame. Then, we should use the same set of functions, including group by, summarize, pivot wider, and mutate. This is how the code looks like if we use the pipe operator. It shows the 4 steps that we did in a very clear way. The results for both codes are the same. We can see that the 6 hospitals are having similar death rates for patients of this infectious disease. Moreover, we can imply that this disease is fatal as it resulted in the death rates of more than half of the patients. The second objective is to examine the average inpatient days for each hospital. We demonstrate this using the pipe operator. First, we need to add a new column that carries the value of inpatient days. This is done by the mutate function. The inpatient day is calculated by subtracting hosp dates from the date of outcome. We can see that the inpatient days should all be greater or equal to 0, since the date of death or recovery should never be earlier than the hospitalization date. Then, we can group the data by hospital and outcomes. The next step is to calculate the average inpatient days for each hospital and outcomes by the summarize function. The average inpatient days are rounded to the nearest integer. Next, we should use pivot wider again to do the conversion, making the results neat and clear. The result looks like this. For all 6 hospitals, it usually takes around 14 to 15 days for a patient to recover and leave the hospital. On the other hand, for those who died from the disease, they receive medical treatments in the hospital for 6 to 7 days before death. The last objective is to understand the stages of the disease. Do you still remember the chart we obtained in Module 7? We can use this chart to examine the trend of disease. From 2014, the disease came back again and it quickly reached the peak in late 2014. We can outline 3 stages for the diseases from April 26, 2014, which is the date that the disease returned. The first stage is the initiation stage. The number of cases is rising, but not in a very fast speed. In the second stage, the disease spread rapidly via human infection. Therefore, we call this stage as the acceleration stage. Lastly, the third stage started after the disease reached the peak. In this stage, spread of disease slowed down, so it is called the deceleration stage. Now, let's examine the death rates for each stage of each hospital. This table shows the number of deaths, number of recovery, and the death rates for each hospital in the initiation stage. We can see that the Port Hospital has the lowest death rate, while the Mercy Hospital has the highest death rate. As for the second stage, the acceleration stage, the death rates of the 6 hospitals are similar, ranging from 50.5% to 56.5%. All hospitals except for Mercy Hospital have higher death rates in this stage. This might imply the seriousness of the disease in this period of time. And the third stage, the overall death rate is still high. Among all the hospitals, we can discover that the death rate for the Port Hospital became very high, indicating that the hospital is facing some problems or difficulties in this stage. Next, we can examine the death rate change for each stage with this code. According to the result, Port Hospital has highest increase in death rates for stage 1 to stage 2 and stage 2 to stage 3. This result also implies that the hospital should take measures to improve the treatment outcome. What can we do after getting this insight? Suppose that we are the management team in the Port Hospital. After we did the data analysis, we found out that our hospital experienced very high death rates in the third stage, which is from September 30, 2014 onwards. Moreover, the death rate in our hospital is increasing for these stages. All these insights act as a warning for the hospital, as it may imply a worse resource allocation in the hospital, poor medical treatment, lack of knowledge to the disease, or other critical issues of the hospital. As a management team, we should find possible solutions to cope with this problem and try to lower the death rates of our patients. If we found out that the hospital is not allocating resources efficiently, we can use optimization techniques to find out the optimal way of resource allocation. The improvement of resource allocation may increase the recovery rate of patients in Port Hospital. We will not go into details about optimization here. The reason for pointing this concept out is to let you know that there are many more data analysis tools available. In addition, this also indicates that data analysis may assist problem solving and decision making. Therefore, it is very important to acquire data analysis skills. We are done with all the analysis of this disease dataset. Hope you obtain a better understanding of how real-world data analysis works. The pipe operator is a very useful tool for you to write a clear codes. Please be familiar with how to use it. Here is the review table for your reference. Please take a look and see you in the next module.